Hi, in this video we will learn how to add forces together so that we find the resultant force. So we'll be looking at one-dimensional problems like this, and we'll also look at two-dimensional problems dealing with perpendicular forces. We'll also look at cases where we have forces inclined at certain angles like the ones we have in the pictures here. Okay, let's begin. Now, before we start, let's look at a little bit of sign convention that we'll be using. So let's have this sign convention. We'll have the direction and the sign that is given to that direction. Let's begin with the right direction. So right, I mean this direction here. By convention, all forces to the right are given a positive sign. In other words, they are positive. All forces to the left, by left we mean this direction. All forces to the left are given a negative sign. All forces upwards, by up we mean this, they are given a positive sign. And all forces downwards are given a negative sign. So this is the sign convention that we'll be using to add and subtract forces. Okay, so let's begin with this one-dimensional problem. We have a block, perhaps, and then we have two forces, a force of 8 newtons. So let's suppose someone is pulling this block with 8 newtons towards the right, and then we have a force of 3 newtons towards the left. So 3 newtons also. Suppose someone is pulling this object towards the left with a force of 3 newtons. Now, obviously, the stronger one is going to take this block. So by mere looking at the diagram, we can tell that the block is going to move towards the right because this force towards the right is actually greater than the force towards the left. But this object is going to move towards the right, not with 8 newtons, but rather with the force that we call the resultant force, which we are going to calculate. Okay, so before we start calculating the resultant force, let's look at forces to the left. I'll call that FL. So we only have 3 newtons. Okay. Let's look at forces to the right. I'll call that FR. So that's only 8 newtons, obviously, from there. Now the resultant force, you can call that total force if you like. Resultant force, or if you like, let's call it total force. I'm going to denote that with letter F. So F is going to be equal to the sum of forces, of course, since I'm finding the total force. So I add all the forces to the right plus all the forces to the left. Can begin with whichever I want. So there we go. The forces to the right, we only have one force of 8 newtons. The forces to the left, we only have one force of 3 newtons. But by convention, we know that all forces to the left are given a negative sign. So I'm going to call this negative 3 newtons. That's by convention. So 8 plus negative 3 is 5 newtons. And since our answer is a positive value, that tells me that the resultant force is 3 newtons. So the resultant force is, 5 newtons, not 3 newtons, is 5 newtons to the right. Because my final force has a positive value, so that means the force is actually pointing to the right. Okay, so this is interesting. Before I move on to the next problem, let me show you a couple of ways we could have drawn this diagram here, this force diagram. So if we had this diagram drawn like this, if we had a block of mass here, and then we have a force of 3 newtons to the left, and a force of and a force of 8 newtons to the right, but all of them being applied to this side of the block, this would totally carry the same sense and it would be the same diagram. We could also have drawn this in another way, perhaps like this, if this is our object, and then we have the 8 Newton force here, and then we have the 3 Newton force. This would also carry the same sense, and it would be ultimately the same meaning. So this would still be the same diagram, if you like. Also, if we drew this diagram like this, and we indicate the 3 Newton force like that to the left, and also we indicate the 8 Newton force, the 8 Newton force to the right, this would also carry the same meaning. So this is very important because force diagrams can be drawn in a variety of ways. What I'm trying to show you here though is that what matters is not where the force is applied, but the direction of the force. So the direction of the force is most important when it comes to finding the resultant force. Let's have more problems, more questions. So here we go. We have 3 forces acting on an object. Like previously, let's find all the forces to the left. I call that FL. So how many forces are actually pointing to the left? We have only one force of 12 newtons. So we have only 12 newtons. I'll write that. Then let's look at forces to the right. Let's look at the forces to the right. We have 2 forces, 7 newtons and 8 newtons. So there we go, 8 newtons plus 7 newtons. And that's going to be 15 newtons. Okay, this is a force to the right. Let's go ahead and find the resultant force, or the total force. Okay, I'll call that F. So the total force is equal to the forces to the right plus the forces to the left. The forces to the right, we have 15 newtons, plus the forces to the left, we have 12 newtons. Okay, newtons. But because these forces are to the left, I put a negative sign. Just correct this better. So 15 newtons plus negative 12 newtons, and there we have 3 newtons. Since this is positive, we'll conclude that the total force is 3 newtons. 3 newtons to the right. By the way, why are we doing this? As you understand, force is a vector quantity, so it has both the magnitude and the direction. That's very important when stating a force. Also, notice that I could have drawn this diagram in a number of ways. I could have drawn it like this. This is our object. I could place all the forces. Just make this a little bit bigger. I could place all the forces on the same direction. For example, here, I could put this 12 newtons here. Then I put the 7 newtons here. And then also the 8 newtons here. And still it would carry the same meaning. What matters, like we said previously, is not where the forces are applied. What matters to us is the direction of the force. I could also put 12 newtons here. Then I put the other 8 newton force and the 7 newton force to this side, but pointing in the same direction. This would also carry the same meaning, and several other diagrams. So still, the direction of the force is most important, not the position where the forces are applied. Okay, we have a 2-dimensional problem here yet. Still, we have forces acting upwards and forces acting upwards. So let's look at the upward forces. I'll call that FU. Those are upward forces. We have a force, should I say upward? Okay, so we have only one force of 7 newtons. That's one force of 7 newtons. Let's look at the downward forces. We have only this for upward. So let's look at the downward forces. I'll call that FD. So the downward forces, we have a force of 4 newtons. Here we go. We also have a force of 3 newtons here. We also have a force of 2 newtons. There we go. 3 plus 4 plus 2, that's 9 newtons. Let's find the total force on this object. Let's call that F. So the total force is going to be equal to the forces in the upward direction plus forces in the downward direction. Let's look at the forces in the upward direction. We have only 7 newtons. The forces in the downward direction, remember by convention, all forces in the downward direction are given a negative sign, so they all add up to negative, that's negative 9, yes. So if you add the 2, you have negative 2 newtons. What's the significance of this negative? The negative actually tells us that the total force is acting in the downward direction, because by convention, all forces that act downwards are given a negative sign. So if we conclude here, the total force is 2 newtons downwards. I don't put the negative because I have stated the direction. So the magnitude is 2 newtons, the direction is downwards. Again, this diagram can be drawn in a number of ways. Try redrawing this diagram in several other techniques or several other ways. For example, I could put all the downward forces down here. So I could have the 4 Newton force down here, this 3 Newton force, and the 2 Newton force. By the way, the length of my vectors do not necessarily represent the magnitudes here, but ideally that's what it should be. And then we can put the 7 Newton force here and it would still be the same. So take note of that in all diagrams that we are drawing, that the direction is so important and not the position where they are placed. So problem 4, let's look at this. We have forces that are perpendicular to each other. This is a big mass. Let's try to represent this in terms of a point mass. So we have a force of 3 newtons and a force of 4 newtons. So let's say 2 people are pulling this object, one in this direction to the right, and another person is pulling it upwards. Where do you think the object will move? Towards the left, or towards the right, or upwards? Ideally, the object is actually going to move in either directions. It's going to move in both directions, So it's going to move upwards and to the right at the same time, but the 4 Newton force is a little bit greater, so the object will actually move to this direction, up and to the right, but more inclined to this axis because this 4 Newton force is greater. But that's not so important. What is important though is that the resultant force is going to be in this direction. So let's call the resultant force F. Now, using simple laws of trigonometry, I can translate this force. So the 3 Newton force, could just translate that force and bring it here just to complete this force diagram and make it easier to add the forces. So this is now the same as this little triangle here, where we have forces F, then we have 3 newtons, then we have 4 newtons. And so by using Pythagoras theorem, we can actually find what the resultant force is here. This is going to be 4 squared plus 3 squared equals F squared. Okay, this is going to be 16 plus 9 equals F squared. 25 equals F squared. So F is going to be 5 newtons. So that's the magnitude of the force, but we do not know the direction yet. In this case, it is easier to state the direction in terms of the angle of inclination to the horizontal, because you cannot say it's right or upwards, so you have to state it in terms of the angle. Let's call the angle of inclination of this force, let's call it theta. Now, that theta, of course, is this angle here. I can find tan theta using the simple rules of trigonometry, sine, cosine, or tangent. Let's use tangent, so we can see that tan theta is actually equal to 3, the opposite, over 4. Let's put this on the calculator, arctan of 3 over 4. So just a moment, do this on the calculator. Okay, that's about 36.9 degrees. Okay, so let's now write our final solution here, that the resultant force, or the total force, is 5 newtons at an angle of 36.9 degrees to the horizontal. So that's our final solution. Okay, let's have more problems here. So we have forces acting in all the 4 directions, I guess. There we go. Okay, let's begin with this. Quickly, let's look at the upward forces. I'll call that Fu. So we have this 3 Newton force, it's upwards. We have the 10 Newton force, it's upwards. So that gives us a total of, what's that? That's going to be 13 newtons. Okay, let's look at the downward forces. Oops. Okay, sorry. Let's have downward forces. There we have, I call this FD. So downward forces, we have only 21 newtons. So let's look at the total vertical force. This is important. The total vertical force. Vertical means forces in this direction, up or down. So let's look at this. This is going to be equal to the forces upwards plus the forces downwards. The upward forces, we have 13 newtons. The downward forces, that's 21. We know that it's negative because it's downwards. So what's the resultant here? That's 8 newtons, negative 8 newtons. So what does this mean? This actually means 8 newtons in the downward direction. That's what the negative sign implies. Okay, let's look at, so here's this. Let's look at the forces in the horizontal direction. I'll begin with forces to the left. Forces to the right. FR, we have force of 2 newtons and a force of 4 newtons. And that's going to be 6 newtons. Let's look at forces to the left. FL. So we do not have any force that is acting to the left. We don't have any force acting in this direction. So there we go. We say that the total horizontal force, which is equal to the forces to the right plus forces to the left, that's going to be 6 plus 0, that's 6 newtons. and because it is a positive, we'll say it is 6 newtons to the right. Okay, so that's not the end of the story, that's just the start. So what is important now is that we have the resultant or the total force in the vertical direction, and we also have the total force in the horizontal direction. So let's put those two forces together. We have 8 newtons downwards. There we go. Oops. Then we have 6 newtons to the right. So at this point right here, at the mass, we also have a force of 6 newtons to the right. So our resultant force, as previously, is going to be in this direction. So I can translate any force. Let's translate the 8 Newton force. Let's bring it here. So our diagram looks like this, our force diagram. Okay, so we have 8 newtons here, this force here, we've just taken it here. Then we have our resultant force, let's call that F. Then we have 6 newtons here. So still applying Pythagoras theorem, you can see that F squared is going to be 6 squared plus 8 squared. So F squared equals 100. And so F is 10 newtons. The resultant force is 10 newtons. That's the magnitude. Let's find the direction. So this is going to be our direction. Let's call that direction alpha. Let's use tangent. So tan alpha is going to be the opposite, which in this case is 8 divided by 6. So let's put this on the calculator. That's going to be 53.1 degrees. So we conclude that the resultant force is 10 newtons at an angle of 53.1 degrees to the horizontal. Okay, that's nice. Let's look at another example. This time round including forces that are inclined at an angle. So this is a good one. We have a force of 5 newtons acting in the upwards direction. So there we go. And then we have a force of 6 newtons that is inclined at an angle of 30 degrees to the horizontal. Now, what is important in this problem is to split the 6 Newton force back into its vertical and horizontal components. Okay? Also, as the problems become more complex, I will not show all the little steps like finding the forces to the left and the forces to the right. I'll simply find the forces in the horizontal direction and the forces in the vertical direction. I think that will be much easier. Okay, so let's go ahead and split the 6 Newton force. I'll give much attention to the 6 Newton force here because it's a little bit not so obvious. So there we go, we have the horizontal plane. This is not a force, it's just the x-axis, if you like to call that so. And then here we have our point mass, and there we have our 6 Newton force at an angle of 30 degrees. So let's complete this diagram by indicating the components of this 6 Newton force. So before we had the 6 Newton force, it means we had some force here and we also had another force here. And after adding together those two forces, we were able to come up with the 6 Newton force. So let's find out what these original forces were. Okay, let's go ahead and do that. So we'll use the same technique we have used previously. I will translate one of these forces. So let me translate this vertical force. I put it here. Guess that works. So here we go. We have 6 newtons here. We don't know what this force is. We also don't know what this force is, but we have the angle 30 degrees. So using the laws of trigonometry, sine, cosine, and tangent, you can easily tell that this force here is going to be 6 sine 30, which is actually 6 times sine 30 is 1/2. So that's 3 newtons. Okay, let me just show you how I get this. Let's just call this force little a. Let's assume we do not know what that force is, and we call that little a, and let's call this small b also. So there we go. We know that sine of 30 degrees equals the opposite, which is a, divided by the hypotenuse of this triangle, which is 6. So that means a is actually 6 sine 30, which is 3 newtons. You could use the same technique to find b. Let's say cosine of 30, that's going to be the adjacent, which is b, divided by the hypotenuse, which is 6 newtons. So b is actually 6 cos 30. So I don't want to use trigonometric ratios, so I'll have to go ahead and do this by myself. Cos 30 times 6, that's about 5.2 newtons. Yeah, I could have written this as root 3/2, but I don't want to use this for now. I know writing 5.2 is not good enough because there are some errors, but let's just go with that for the moment. So the force in the vertical direction is 6 sine 30. I will not write this for the meantime, but just know that that's the final answer. What's important is this step here, because this is more general and we'll be using such notation later on. Also here, this is b, not 6. So 6 is this side. Okay, so this is 6 sine 30 and this is 6 cos 30. So let's come back to our force diagram, the original diagram, and indicate those two forces. So I'll rub the x-axis here. It's not important to indicate it, but there we go. So the horizontal component of our 6 Newton force is 6 cos 30, and the vertical component is 6 sine 30. Let's go ahead now and find the total force in the vertical direction. Of course, the total force in the vertical direction involves, let's call that Fv. It involves getting the sum of forces in the upward direction plus the sum of forces in the downward direction. So let's go ahead and do that. Do we have any forces in the upward direction? Yes. So, oops, I got to put another arrow here to show that this is the sine 30, and then we also have 5 newtons there. Okay, this is newtons. So the forces in the upward direction, we have 5 newtons. Then we also have, 6 sine 30. I guess that's all we have. There is no downward force, so 0 in the downward direction. So that's going to be 5 plus 3, which is 8 newtons. This is a positive force, so that means it is to the right. Let's look at the horizontal forces. Horizontal forces means to the left or to the right. Okay, there we go. So the horizontal forces we have, if I call that FH, that means the forces to the left, forces to the right plus the forces to the left. So the forces to the right, we actually have this component 6 cos 30. We do not have any force to the left, so our only force here is 5.2 newtons. We've already calculated what this is. Now after finding the horizontal and vertical forces, then we can indicate all these forces on a single force diagram like this. We have 5.2 newtons, of course that's to the right. Sorry, what did I say? This isn't, oops, what am I doing? This is to the right. This is in the upward direction. Okay, so yeah, that's better. So here we have 8 newtons in the upward direction, and then we have 5.2 newtons to the right. Our resultant force is going to be in this direction. Let's call that F. Let's give this angle beta. So I will not repeat the process here. We know that F squared equals 5.2 squared plus 8 squared. So that means F squared equals, let's just calculate that on the calculator here. Okay, this is 91. So let's get the final answer. F is going to be 9.4 newtons. Okay, that's correct. 2 decimal places as well. No, yes, that's 9.54 newtons to 2 decimal places. Also, we can find the angle beta. Okay, that's going to be arctan of 5.2 divided by, that should be 8 divided by 5.2. Can plug in this to the calculator. 8 divided by 5.2, then arctan, sorry, I'm using an offline calculator here. So this is 56.9 degrees. It's actually 97. I think I just say 57 degrees. So the resultant force is this. That's the magnitude, and the direction is 57 degrees, approximately 57 degrees to the horizontal. So there we go. That's how we deal with forces that are inclined at certain angles. So with experience, you'll actually notice that there is an easier way to tell which component is cosine and which component is sine by just looking at where the angle is placed. So the angle here is between the horizontal and the force. So the horizontal component is always going to be cos. For this case, if the angle is between, the angle should be between the direction horizontal or vertical and the force, for you to use the cos component, and then the other side will obviously be sine. Let's suppose we used this angle here, which is 60, then the vertical component would be 6 cos 60, because in this case the angle is between the vertical itself and the force, and this would be 6 sine 60. Yeah, it's that interesting. It would also give the same result. Okay, let's have a next example here. I guess this is like the second last. So we have a force of 3 newtons, 4 newtons and 7 newtons. Let's go ahead and find the, okay, I'm going to begin by resolving, by completing this diagram. Let's indicate this just to help us find the forces that are in this direction, if there exists some. So there we go. Let us resolve the 4 Newton force. I'm going to resolve that using the green color. We know that there is going to be a component here of 4 cos 60. Okay, from what we've looked at previously, you can prove that this is true. We also have a force. Have a force of 4. Just write that here, 4 sine 60 in the upward direction. Let's resolve this force of 3 newtons. I'm going to resolve that in red. So here we have a force of 3 cos 30. Okay, there we go. Also, in the vertical direction, because of the 3 Newton force, we also have there 3 sine 30. Okay, I guess that's it. Also, we have the components indicated, and we can now begin to find the forces, the total forces. Let's say horizontal forces. Okay, let's begin with that. Horizontal forces. Sometimes I write this summation of forces in the x direction. So for this case, let me not do that. So let's just say horizontal forces. Let's begin with forces to the right. Then we'll add the forces to the left. So let's write the forces to the right. We have 4 cos 60. 4 cos 60. Any other force to the right? We actually don't have any, so there we go, stop there. Plus negative, because all forces to the left are negative, so I'll indicate negative before adding them here. We have 3 cos 30. And that's it, I guess. There is no other force in the horizontal direction. So let's just add this together and see what we have. 4 cos 60. Okay, cos 60 is, I guess, half. So this is 2. And then, oops, just write minus here. 3 cos 30. 3 cos 30 is 2.59. 2.59, so I'll just approximate that to be 2.6. And so the result here is negative 0.6 newtons. So this means 0.6 newtons to the left. That's all we have in the horizontal. Let's look at the vertical. Let's look at the vertical forces. So for the vertical forces, sometimes I call that summation of forces in the y direction. But let's just add the forces manually. So that's equal to the forces upwards plus the forces downwards. So let's look at the forces upwards. We have 3 sine 30. We also have another force of 4 sine 60. It's also in the upward direction. 4 sine 60. Plus, all forces downwards are given a negative sign. So I'll say minus 7 newtons. So let's find out what the total force is in that case. Sine 30 is 1.5. So 3 sine 30 is actually 1.5 plus 4 sine 60. So I'll just give you the final answer here. 4 sine 60. I guess let's just do this. I'll just write the final answer here. 4.96 minus 7. Okay, so we don't do that. Oops, 4.96 minus 7, that's negative 2.04 newtons. So this actually means 2.04 newtons downwards. Let's draw a final diagram for this force. This force diagram here, we have a force of 2.04 newtons downwards, Then we have a force of 0.6 newtons to the left. There we go, 0.6 newtons. And I guess now you can be able to find what the resultant force F is, because F squared. Okay, also let's put the angle of inclination. Let's call that angle alpha. So F squared equals 0.6 squared plus 2.04 squared. So I'll just give you what the final answer is there. Plus 0.6 squared and under square root. Okay, I'm not sure how correct my answers are because I'm doing this so fast. I guess that's 2.13 newtons. That's our resultant force. We can go ahead and find the direction. Let's do that. The direction of this force alpha is going to be arctan of the vertical force here is 2.04 divided by 0.6. Let's do that. 2.04 divided by 0.6. Arctan of that is, I guess this is 73.6 degrees. So the resultant force is 2.13 newtons in magnitude, inclined at 73.6 degrees to the horizontal. Okay, this is a nice one. Let's have our last problem. There we go. We have three forces, 7, 10, and 8 newtons. Let's go ahead and find the vertical forces first. Vertical forces, let's do this first. For this case, we have, okay, I guess we started the wrong way. Let's begin by resolving this 10 Newton force. So I'll use that green color. So this component is going to be 10. You see the angle is actually here. So this is cos 45. If the angle is here, then that would be sine. Okay, so that's 10 cos 45. Also, there is a component here of the 10 Newton force, and that's going to be 10 sine 45. So the vertical forces, we actually have, that's upward forces plus downward forces. So the upward forces, we have 7 newtons. The downward forces, we have 10 cosine of 45. What's that? So 7 minus 10 cosine of 45 degrees. I'll just give you what the final answer is. Oops, this is so small. 0.071 newtons. Okay, it's a moment. I'm going to do this twice, see if that's correct. Okay, I guess that's right. 0.071 newtons in the vertical direction. This is a positive value, so that means this force is upwards. I'll just write an arrow. Let's also find the horizontal forces. Let's find the horizontal forces. So let's use this. So the horizontal forces are equal to forces to the right plus the forces to the left. So the forces to the right, oops, we have no force to the right, and then the forces to the left, we have 10, 10 sine 45. We also have a force of 8 newtons, this and this. So our total force in this case is going to be, let me add that, 8 plus 10 sine 45. It's going to be, okay, 15, negative 15.071. So this is, what's this? This is 15.071 in the, okay, that's to the right, because all forces to the right are, by convention, they are negative. So there we go. Now we can draw our final force diagram. We have a force of 15.071 to the left, and we have an upward force, okay, That's 0.071 newtons. So the resultant force is going to be in this direction. Let's call that F. So we can know what F is. F squared equals 15.071 squared plus 0.071 squared. I don't want to do this on the calculator. There are like too many numbers. So I beg that you go ahead and calculate what this is. Also find the angle to the horizontal, and let's call that theta. That's going to be the direction of the resultant force that you will find. Okay, thanks for watching this video. Please help me grow this channel by subscribing, liking the videos, sharing with friends, and comment below for more ideas of what videos I should make that suit your needs. Thanks for watching. See you again.